Everyone, myself Sandeep Javheri, Assistant Professor, Department of Civil Engineering from Walchand Institute of Technology, Solapur. In today's session, we are going to discuss about special concrete. There is an elective for BTech final year students, that is repairs and rehabilitation of structures. So, this is a part of that subject. The learning outcome: at the end of this session, the students will be able to explain what are the features of special concrete. The special concretes are nothing but the concrete that are prepared for specific purpose like lightweight, high density, fire protection, radiation, shielding, etc. And this concrete is a versatile material having good compressive strength. The list of special concretes are polymer concrete, sulfur infiltrated concrete, ferrocement concrete, and bacterial concrete. Also, vacuum concrete and fiber reinforced concrete. Let us see these concretes one by one. So, the types of special concrete as described here. Let us see about polymer concrete. So let us discuss polymer concrete. Polymer concrete is a composite material made by fully replacing the cement, binder or supplement to the cement concrete with polymer binders or liquid resins, and is a kind of concrete polymer composite. The types of polymer concretes are, we can say a polymer concrete as a PC, that means when the binder is a polymer that replaces cement paste. We can say polymer modified concrete as PMC, when the polymer is mixed along with the cement. Then we can say polymer impregnated concrete, that is PIC, when the cement concrete is treated by soaking and polymerization. Polymerization means we are going to apply the chemical reactions in a monomers, and there is a multiple number of monomers are present. That is called a process of polymerization. So, partially impregnated and surface coated polymer concrete is also one of the type of polymer concrete. Now, polymer concrete is useful in large number of applications such as marine works, prefabricated structural elements, pre-stressed concrete, nuclear power plants, sewage works, and desalination plants. So, in case of thermal plants, we have so many plants available for working purpose. So, one of the plant is called as desalination plant. Now, waterproofing of structures and numerous industrial applications are also there where the polymer concrete is used. So, mostly in repair works we can adopt polymer concrete. Now, these are the properties of polymer concrete. Let us see bending strength. It has a bending strength of 20 megapascal, shear strength of 20 megapascal, compressive strength having value range up to 90 megapascal. So, there is a large amount of improvement in compressive strength. Then modulus of elasticity, that is 22,000 megapascal, specific gravity 2200 kg per meter cube, water absorption, that is very less, 0.05% by weight, that means lesser than 1%. Then operating temperature up to 80 degrees centigrade. So, it can sustain in larger value of temperature also. Then surface roughness, that is 25 micrometer. Now, this is a typical sketch of a structural element. It is made up of polymer concrete. Then let us look towards sulfur infiltrated concrete. Sulfur infiltrated concrete was developed as an economical alternative to polymer impregnated concrete, that is PIC. PIC is to be used for higher strength and durable precast elements. Sulfur is considerably cheaper than polymers and the technique of impregnation is more simple. Hence, because of this, it is a cost benefit product. Since sulfur infiltrated concrete is a composite construction material, consists of mainly sulfur and aggregate, generally a coarse aggregate which is made up of gravel or crushed rocks and a fine aggregate such as sand. Cement and water, important compounds in normal concrete, are not a part of sulfur concrete. Now, what are the applications of sulfur infiltrated concrete? These are precast roofing element in case of fencing post, in case of sewer pipes. In case of sewer pipes, this concrete is used. Also in case of railway sleepers, then for industrial pump application where high corrosion resistance is required. Also in precast concrete units, this is also having advantage of cost. That means the cost is very cheap from commercial point of view. The sulfur infiltrated concrete, the picture shows the structural element which is prepared with the help of or by using sulfur infiltrated concrete. Now let us consider what is ferrocement concrete. A ferrocement is a type of reinforced concrete which is composed of concrete with small aggregates or coarse mortar having 12 to 30 mm thick reinforcement with minimum of 2 layers of small diameter which are placed orthogonally, that means perpendicular to each other, having woven coir mesh which is separated by 3 to 6 mm diameter galvanized spacer wires. The mortar is made with plasticizer and polymer to make it dense without any pores. So this is a picture which shows the layers of reinforcement with a very small diameter wires woven and they are placed orthogonally, that means perpendicular to each other, and this is a casted by using a mixture of polymers. A mixture of polymers and plasticizers is added for casting in a dense form, and this can be used for fencing purpose or for precast structures such as pardi, slab, panels, etc. Now let us consider bacterial concrete. Now bacterial concrete is also called as self-healing concrete or microbial concrete. It is a type of concrete that can biologically produce limestone to heal the cracks that appear on the surface of any concrete structures. As you are aware that the structural elements undergoes cracks due to tension, due to temperature difference or thermal stresses. So what is the working of bacteria on concrete? Upon exposure to environment, the spores of bacteria germinate on contact with water and nutrients. Bacteria starts to feed on calcium lactate. So calcium lactate acts as a nutrient. So when it is activated, it starts to feed on calcium lactate. Then oxygen is consumed and soluble calcium lactate is converted into insoluble limestone, and the limestone solidifies on the cracked surface, thereby sealing it up. So consumption of oxygen also increases the durability of steel reinforced concrete constructions. So the microbial concrete, it helps to improve the durability. Also it helps to seal the cracks which are occurred on the surface of the structural element. Now this is a picture which shows the process, how the process happened. Here the bacteria are present. Then these are the special type of bacteria such as bacillus bacteria, and they have food, that is calcium lactate. After activation it forms insoluble forms of limestone. This helps to seal and block the cracks. So the applications in cement mortar, in precast concrete, to fill the gaps or to seal the cracks, it acts as a crack filling material. In brick production, to cover to pervious concrete, and also in the mass production of concrete. Now you are supposed to pause the video and answer this question. The first question, that means a bacterial concrete is also called as, the options are given. The second question, in case of sulfur impregnated concrete, sulfur is considerably cheaper than polymers and the techniques of impregnation is more simple. So the answers are, as we know that bacterial concrete is called as a self-healing concrete, so A is the correct option. Then also the sulfur impregnated concrete is considerably cheaper than the polymers, because polymers is costly little bit than the sulfur impregnated concrete. It's a true statement. Thank you.